This video is to show how to use STAAD.Pro to draw the shear and the moment diagrams. And today's example is a beam example. The total length of the beam is 6 meters, and this beam has a roller support at A and a pinned support at B. Subject to a triangular shape of distributed load, has the maximum magnitude 4 kN per meter. And now we open the STAAD.Pro software. And the first thing to do is configure and make sure the base unit match the original model. And the original model has kilonewton and meter, so we will choose metric and leave other things default and click OK. Then do a new model. First put the file name and then select a folder that you want to save the files. Double check the type is analytical and unit is metric. So now we can go to job information. And for a job, I put STAAD session 4. This is called beam, shear, and moment diagrams. And then put clan RIT and enter job number as a course number. Reference, I put the beam, moment, shear and moment diagrams. Class example. Then enter engineer and put the date. The command is use STAAD to draw shear and moment diagram. And compare the results. With hand calculations. So after that, we do a create. Now we enter this analytical modeling window, and we will do the input from geometry, and then properties, materials, specification, support, loading, and analysis will be done at analysis. Before we do the geometry input, we need to make sure that input unit match the original model. So we just go to this right bottom corner and has this input unit currently set as kilonewton meter. Okay, so if this doesn't match your model, you need to go to this input unit, hit this button, and go to the metric unit system and select meter and kilonewton and apply. Then we can input the coordinates of the 3 nodes. And for the model, we have 3 nodes, 1, 2, 3, and it has a coordinate 0, 0, 0, 3, 0, 0, and 6, 0, 0. And we manually input these 3 coordinates. Okay, so after that, we want to see this screen just in the XY plane for the 2D structure. So we go to the view and use this front view button. And now we just see XY plane. Then go back to geometry. And now we want to add a beam to link the nodes to draw the beam members. So we use this add beam button. Then connect node 1 to node 2. And node 2 to node 3. Then escape. And also for geometry, I want to see the location of each node. as well as the node number and the beam numbers. So I just put my mouse in the screen, right-click, and go down to the labels. Then check node numbers, node points, and beam numbers. Then click OK. So now you can see the node numbers as well as the beam numbers. So we're done with geometry and go to properties. And for this beam, we want to set the beam as a 21 by 44 W shape. So we need to use section database. So in this section profile table, we'll select the steel W shape, and then from this list, select 21 by 44. And check material, steel, and do add. Then close. After that, highlight this 21 by 44 and use Assign to View. So both numbers shown on the screen has the same section properties. So we just do Assign. So now we're done with section properties and go to the right, Materials. And since we assign the section properties as a W shape, the program will carry the steel's material properties to materials. Now we just need to double check. Okay, and accept it, go to specifications. And specification tab is to release the moment at pinned connection. And we have today's example is just one continuous beam, and there's no pinned connection in the middle. Therefore, we don't need to release anything for this model. And then we can just skip the specifications and go to the supports. And for this model, we have a roller support at A and pin support at B. So we need to create, first, for the roller support, we use fixed butt, release Fx and Mz for the roller support and do add. And then create the pinned support. Just select this pinned support and do add. And after that, highlight the roller support. Use cursor to assign and assign to node 2. And escape. Then highlight the pinned support. Use cursor to assign to node 3. And escape. So now we're done with supports. And go to the right, loading. And for this example, the original loading is a triangular shape. But when we draw the number, we actually create a middle point, which is node 2. So when we assign the member load, we need to actually define two member loads. One is from 0 to -2 kilonewton per meter, and the other is from 2 kilonewton per meter to 4 kilonewton per meter. That is the trapezoidal shape on member 2. So based on the shape of the load, we need to define that in the STAAD.Pro. And the first thing to do is highlight the load case details to add a load case. And for this load case, we want to just select a live load case and put title as live load. And do add. Then you see the add load under the load case details. And we just do one load case. So close it and then highlight the live load and do add. To add load items, so for this one, we want to do the member load and select trapezoidal option. And we put the first load on member 1. It starts with 0, W10, and end at -2 in the global Y direction. Negative means downward direction. And since this load occupied the entire member 1, so we can leave D1 and D2 blank. Okay, and just do add. And then on member 2, also a trapezoidal shape, W1 change to -2, and W2 is -4. Direction is global Y direction. And do add. And close. Then we highlight the first trapezoidal shape from 0 to -2 and use cursor to assign and assign to member 1. Then escape. Highlight the trapezoidal shape -2 to -4 and use cursor to assign to member 2 and escape. So now we're done with loading. And move to the right, analysis. And for analysis, we use this define command and just leave everything default. Choose this print option, no print, and add. And after that, you should see this perform analysis command show up in this analysis window, and then close. So after that, we just save the model. We don't need to define any post-analysis command for shear and moment diagrams. So we can just do a run analysis after we save the file. So after the analysis done, and we will go to post-processing mode. So we will choose the second one, go to post-processing mode for shear and moment diagram. So hit down, and in this pop-up result setup window, just choose OK. Okay, so now is the post-processing window. And today we are interested in the shear and the moment diagrams. So we just go to the beam results. And after hit beam results, we just want to maximize this window. And now you can see the moment diagrams, but the scale doesn't look correct. Then you can hit Control and roll your mouse to change the scale of the diagram. Okay, so now it's look good. And based on the results, now you see those buttons. Now you have this result tab and the buttons. So for 2D model, for 2D structure, Fx is the axial force. Fy is the shear force. And Mz is the bending moment. So we're just interested in Fx, Fy, and Mz for 2D structure. And currently, the Mz is showing on the screen, but without any numbers. In order to show the numbers on the moment diagram, we need to do this annotate. Then, from this window, we select the beam results and turn on the bending, the end value, and the maximum value. And for shear, turn on the end and the maximum. And then hit annotate. So just say yes, because currently the shear diagram is not on. So we just say OK. And then close. So after that, you see the numbers on the moment diagram. And the maximum is 3 kilonewton meter. Okay, but you cannot see that in the middle part. Okay. I will show you how to get those later. And if you want to see the shear diagram, you need to turn off the moment diagram and turn on the shear diagram. And now we need to change the scale by using hold Control and roll your mouse to change the scale of the shear diagram. And you also see the shear diagram has the number. Okay? And all those numbers match our hand calculation. Okay? And let's go back to the moment diagram. So now I turn off the shear diagram and turn back to the moment diagram. And just compare the moment diagram with our hand calculation, and we notice that for STAAD, the moment diagram is on the opposite side to our hand calculation. So the reason why is STAAD.Pro use the sign convention. They always draw the diagram on the beam tension side. Instead, for our hand calculation, we draw the moment diagrams on the compression side. So although it shows exactly the same numbers, but it's on a different side. So this is just due to the sign convention in the STAAD.Pro program and our hand calculation. Another way to show the shear and the moment diagram is using this layout. And then for beam results, we select the graph layout, the graphs. So after that, and this window show up, and you can select any members in the model to see the moment and shear diagram. For example, so if we select the member 1 and the right-hand side and show the moment diagram, shear diagram, as well as axial load. And for this beam, and we know the axial load equal to 0. That's why for the axial load part, you just see 0. And for the shear diagram, we start from 0 and to -3, which match our hand calculation. And for the moment diagram, it starts at 0 and end at 3. And the diagram for STAAD is on the tension side. Okay, so for member 2, this is the moment diagram and shear diagram and axial load. And in this diagram, you can see the maximum. The local maximum here is 2.11, which match our hand calculation. Okay. And if you want to see the diagram clearly, and you can maximize it. Go back. The shear. And for member 1, shear diagram. And a moment diagram. Okay, so now we're done with today's example.